So what can we do to defend against denial of service? Let's take a look at some common countermeasures. We could try to identify illegitimate increases in traffic or some flash events, like suddenly there's a big burst of activity. An attack is an abnormal or obvious deviation from normal traffic. So different detection techniques, we could profile normal activity. We could see at what point there are changes. We could do something called wavelet-based signal analysis. I'm going to talk about that in a sec. So activity profiling, we look at what's normal. So an attack is identified by an increase in activity of clusters of machines, net flow clusters. And so if we just see like little hot spots suddenly, we can wonder about that. So we'll create an activity profile based on the average packet rate for whatever that part of the network is. And we'll use network packet header information, which we'll monitor to get activity profiles. In other words, what's normal for different parts of the network. Changepoint detection. We could use algorithms to identify changes in network traffic statistics. We could, so we're maybe isolating or filtering traffic. We could use changepoint detection algorithms to filter targeted traffic data and store flows as a time series. So we could, well, what's different about network traffic stats? We could identify the attack. So there could be sequential techniques like the CUSUM algorithm, which is basically the analysis of probability distribution, to identify and locate denial of service attacks. And we can identify scan activity. So we could see, is there a lot of worm scanning activity going on as well? So basically just different ways of looking for changes in the network. The wavelet-based signal analysis, we're using, it borrows from signal processing techniques that are not related to networking per se, but we're applying it to network anomalies like DoS and port scans. So it looks at input signal based on components, spectral components. And what we're doing is we're looking at simultaneous time and frequency descriptions. In other words, in a certain amount of time and certain frequencies, like how often is this happening? And when we see anomalies, we see like the amount of time going on or the frequency changing. We basically see increases in energy in whatever the normal flow is. And the time of each frequency component, each time these are active, is determined by our analysis. So what we're basically looking at is for hotspots that suddenly peak or stay longer. And this is effective against unknown anomalies because you're basically starting with a baseline, but just not the overall traffic. It's more like in all these areas, we expect certain protocols to be like this for certain amounts of time with certain clusters of machines. If those components start changing and we start seeing hotspots, it's longer, it's more for one protocol, it's more for one set of machines. Then we do that sort of more sophisticated analysis to say, hang on a second. Rather than the DDoS being lost maybe in like an overall traffic throughput, which would hide those kinds of details. So what are our countermeasure strategies? Well, we could absorb the attack. We could get cloud-based filtering. There are whole services that will basically rent you their entire cloud, I mean you and other customers. And entry point for them, that looks like your web server. Your web server is actually down here. So all the denial of service that comes in, they've got all these filters down here that will respond automatically and just absorb and clear out all the garbage so that legitimate requests come down to you. So we could have the ability to absorb attacks. Of course, you need a huge amount of network capacity and load balancing to do that. It requires planning and additional services. You could just flat out shut down services until the attack is over. You could shut down non-critical services or shut down all services. Sometimes it's all you can do. You also need to make sure that there isn't any collateral damage here. You need to protect your secondary victims. So if something's starting to happen, everybody else needs to quickly get installed and up to date with their antivirus, anti-Trojan software. Or you can at least isolate the infected area from everyone else. You can make sure there's increased awareness of security issues and prevention techniques. Disable all services that are unnecessary. Uninstall apps that aren't used. Scan files from external sources. And you can configure and update any built-in mechanisms for hardware and software defense. You'll need to find and neutralize those handlers. So network traffic analysis, identify potentially infected network nodes through analysis of all the protocols, traffic patterns, because maybe you've got a handler plus a whole bunch of zombies on your network. So if we can neutralize the handler, we've effectively neutralized the zombies until they can all be cleaned out. So try to neutralize those botnet handlers. The fewer DDoS handlers there are, then the fewer commands are going to get out to your all those zombies there. And also, you're going to need to look at spoof source addresses. Make sure that any source addresses are actually valid. Look for those spoofed addresses. Filter. Coming in, going out. Ingress, egress. So scan packet headers of packets leaving the network to make sure that unauthorized or malicious traffic can't leave. Or protect from flooding attacks by enabling the originator to be traced back to the source. Or prevent the DoS attacks by configuring TCP intercept to basically validate all TCP connection requests first before they're even tried by the server. And you can have firewalls and things do that. You could also use honeypots and honey nets to sort of deflect the attack so that they'll be focusing on something unimportant. You can gather information about your attackers while they're busy with the honeypot or the honey net. You're going to want to have defense in depth with intrusion prevention as well as honeypots that will attract away your suspicious DoS traffic. You could increase bandwidth for critical connections. You could have additional servers that are replicating for extra fail-safe protection. You could have load balancing so that they can absorb some of the DoS attacks. You could make sure that routers are set to access the servers with some kind of logic to throttle incoming traffic levels to a level that's safe for the server. So we could throttle DoS traffic to minimize damage to servers. But the problem, of course, is you throttle DoS traffic, you're throttling legitimate traffic too. So just be aware of that. After the attack, you'll want to do some post-attack forensics. Maybe develop some new filtering techniques based on the DDoS traffic patterns you saw. You'll want to look at the DOS traffic sources by analyzing your firewall and router and IDS logs. Analyze the DOS traffic for certain characteristics. Maybe it's always a certain port or certain time or coming from certain IP addresses. And use these characteristics in pattern analysis to update your load balancing or your throttling countermeasures. So those are some common things we can do to help mitigate the impact of DDoS attacks.